Hi, I'm back. We're continuing on with week 3, the guided worksheet for section 1.5. We just finished up problem 3 on using the quadratic formula to solve quadratic equations. And now we're on to our last method that we're going to take a look at for solving these equations. And that's going to be using your graphing calculator. So the solutions of the quadratic equation, ax squared plus bx plus c is equal to 0, we know those are called the zeros. Well, it happens that they correspond to the x-intercepts of the graph of the left-hand side of that equation. Let's go work through an example to use our graphing calculator to find the solutions of 2x squared plus 7x minus 4 is equal to 0. Essentially what we're going to do is we're going to see the steps we need to do to find the x-intercepts, and we're going to have the calculator determine that for us. Notice that the graph of a quadratic is U-shaped. It's called a parabola, and sometimes that parabola will be cupped up, and sometimes it'll be cupped down. All right, step 1, go to y equals in your calculator, and under y1 type in this equation, this formula. Next, we have to set a good viewing window. So I gave you this window suggestion. Remember how it goes. It's x1, x-min, x-max, x-scale by y-min, y-max, y-scale. And I just typed in those corresponding numbers here in the window. Then press graph. What we see and what we want to notice in this case are, visually, graphically, what do the solutions look like to a quadratic equation? Well, they turn out to be the x-coordinates, right, of the x-intercepts. So we should expect 2 solutions to this quadratic equation. Well, to find them, we need to get to what's called the calc menu. So the way you get to the calc menu is to press second trace. The trace button is right next to the graph button, and you see the words calc above it. So we have to use that second function to get there. This is what it'll look like. Okay, what you would like to do is you'd like to choose 2, 0, because we're trying to find the zeros. We've already noticed that there are 2 x-intercepts, and now your calculator is going to prompt you. It's going to say, well, what would you like the left bound to be for your first x-intercept? Well, you notice there's 2 of them, so we have a choice. I'm going to work on finding this x-intercept first. So to set the left bound, what you want to do is take a look at the arrows under the graph key on your calculator. There's up, down, right, and left. You'd like to use the left arrow, and you want to move the cursor to be above this x-intercept. I'm going to choose this one to work on first. So above it means we're like a little bit to the left of it. So here we notice my cursor started out about here. So if I start out about here and I use my left arrow, it's going to travel along the curve, and I want it to go a bit to the left in x values, past that x-intercept. So here I would say that would be my left bound. What we're going to do is we're going to give the calculator bounds, like the left and right bounds of x values where we think the x-intercept is, and then we're going to have it compute the actual intercept. All right, so after you've kind of set your left bound a little bit to the left of where you think the x-intercept is, then press enter. Next, you'll see this screen, and your calculator will ask for a right bound. To set the right bound, we're going to now use the right arrow, and we started here, we left off at the left bound, and we want to just use our right arrow to go down a little bit to the right of, like an x value to the right of where we think it would be on the graph. So let's just say our right bound is about here. So we're going to give like a band in which the calculator will be able to guess the value. Now, after you've determined where that right bound would be. And again, ours might not be exactly the same. It doesn't have to be precise. It's just on one side and on the other side of where you think your x-intercept is, you have to press enter. So after each step, you need to press enter. The calculator will ask you then, do you want me to guess it? So in this last screen here, it says guess. And to say yes, press enter one more time. So in this case, you're going to be pressing enter a total of 3 times. After it guesses it, then it actually will compute the 0. Right? So the 0, the answer is x is equal to -4. And it'll actually show you where it's located on the graph. Notice that the equation, 2x squared plus 7x minus 4, the y value should all be 0, right, for this x value. So we found the 0 on the left, right, I should say, or the x-intercept. Now we have to find the x-intercept over here. Here I just give shortened screenshots. But you're essentially just going to compete the steps 4 through 9. Find the left bound. Now it's going to be below where we think the x-intercept is. So we'll mark that. And then we're going to find the right bound. Use your right arrow to go above. So it's given us, we've given the calculator this band in which to look for the x-intercept. And then we have to guess. So remember, after you move the cursor to the left bound, press enter. Right bound, mark your spot, press enter, and then one more time to guess, press enter. And then we see that the solution is x is equal to 0.5. Right. So we notice that this quadratic equation has 2 different real number zeros, x equals -4 and x equals 1/2. I've just left this problem as a you try it problem and given you the answer. So make sure you can work through these steps. I gave you the calculator window to get these answers. These answers aren't as nice, right? They're with decimals. So I'm rounding to 2 decimal places. Okay, we need to talk about one other important concept in this section. It's called the discriminant. The discriminant is the portion, that algebraic expression under the radical in the quadratic formula. So we're just looking at b squared minus 4ac. It turns out that the discriminant tells us the number and type of solutions of a quadratic equation. It doesn't tell us what the values are. It just gives us an indication of how many and what kind, either real or complex, imaginary, that we can expect. So I'm going to refer us back to the quadratic equations in problem 3, A, B, and C. So I've just copied these down. This is what we did previously. Right. So if you've worked through this guided worksheet, go back and check through your answers. We're just going to really pull out our answers. We did all the work. Now it's just interpreting what we did. So for each of these, I'd like you to find the discriminant. So I'd like you to find b squared minus 4ac. Okay, just this part. Then I'm going to have you graph the left side of each equation. So enter this in y1. And take a look at the x-intercepts. Tell me, how many do you see? Then let's see if we can use the discriminant. And notice we're checking to see if it's 0, if it's positive, or if it's negative, to relate to the number and types of solutions we see. All right, here are the answers below. Okay, first of all, I just went back to problem 3. Remember, this is from problem 3, and I wrote down what we had, right? But let's take a look how it corresponds. So let's just look at the graphs first of all, and then we'll go to the discriminant. Okay, for A, for this quadratic, when I look at the graph, I see that there's 2 intercepts. For B, there's no x-intercepts. Remember, these are x-intercepts we're looking at. And for C, I see it just touches the x-axis at one point. That means there's just one x-intercept. So for this part, for the graph, we just really wanted to observe the number of times the graph either crosses or touches the x-axis. Next, let's take a look at the discriminant b squared minus 4ac. I'm just going to scroll to show you where we found that. So again, close your eyes if you don't want to get too dizzy here. I'll just take a look at it for this example. All right, so let's take a look at it for C. And this is what we did. So remember, this is problem 3C. We're looking at the part that's under the radical. So we just want this part here before we take the square root. And that number turned out to be 0. So this number here, that's the discriminant. So if we take a look at that in each case, go back down. That was for part C. I got a 0 for the discriminant. For B, I got -4. And for A, I had 12. So you notice the discriminant here is positive, it's negative, and here it was 0. So let's try to relate this information. If the discriminant was 0, what did we see? We saw one intercept, x-intercept. That corresponds to one real solution. If the discriminant is negative, there were no intercepts. Well, it turned out that was the problem that had two complex or imaginary solutions. Here, where the discriminant is positive, we see with the graph there's two intercepts, and we did get two different real solutions. So in each case, this is the summary that we come up with for each case. So if the discriminant is 0, we just get one real solution. It's actually what's called a repeated root. If you were to factor it, if you can factor it, you'd actually have two factors of the same type. But it looks like this on the graph, part C. If the discriminant is positive, then we're in case A, and we're going to have two intercepts. Two x-intercepts are going to be two different real number solutions. If the discriminant is negative, as in part B, we're not going to have any x-intercepts, and that corresponds to two complex, they're going to be different, right, imaginary solutions. So that's what the discriminant tells us. It doesn't tell us what those solutions are. It doesn't tell us what the zeros are. It tells us the type, whether they're real or they're complex, and then the number, whether there's 1 or 2. Okay.